Very happy new year to you. This question is from NCRT Exemplar, class 11th physics, the chapter of oscillations. Now, a lot of students I have taught face a very typical problem that they don't understand the mathematical concepts that are used in the chapter of simple harmonic motion. So while the students are very good in the concept of maximum kinetic energy, amplitude, they understand the acceleration, they understand velocity. I think where they take a beating or not able to appreciate the simple harmonic motion is specifically in mathematical areas, and that is my aim today. I want to remove those doubts in the minds of class 11 students. It is not the fault of class 11 students that they are not aware of these concepts. These are heavy duty mathematical concepts. Generally these are taught in class 12th, and specifically if you're not a mathematics student, you have been a biology student, you may find it harder to understand these. So I will make your life simple today, and I understand your pain area that you're not able to solve this problem because you're dumb. It is because of the nature of the problem. Okay. The problem statement is if you're given a sine or a cosine function. For example, you have something like a trigonometric function, and you want to you want to so you have a trigonometric function, right? Why do I say trigonometric function? Because most of S.H.M, right, if you see S.H.M, the displacement is written like a sine omega t, starting from the equilibrium point, right? And velocity is given by a omega cos omega t, and then the acceleration is given by, so I will change the nomenclature to A, capital A, to represent. So minus A omega square sine omega t. You can see a lot of S.H.M parameters like displacement, velocity, and acceleration are expressed in sine, cosine, sine, right? And therefore, a lot of mathematical concepts the class 11 students struggle with are associated with especially the trigonometric aspects, and coupled with another aspect which is integration, right? So students don't know what exactly is integration and how do you link integration and trigonometry. Reason I'm telling you that is if you look into the concepts like average total energy, the average kinetic energy, the mean velocity, the root mean square velocity. These are new to class 11 standard students. They don't know what it is, right? So a class 11 student who's studying oscillations understands the maximum kinetic energy, right? They understand what is the V max. They pretty much understand what is V max. It is equal to A omega. But what they don't understand are these concepts, which I'm going to highlight, right? So the concept of average is not understood by them. The concept of mean is not understood by them. And what is the meaning of the word root mean square velocity is a problem to them. So class 11 student struggle in this area, and that is why I have prepared this video to make your life simple if you're a class 11 student and you don't understand this, right? Let me give you some important points associated with these terminologies, okay? And this will make your life very, very simple, okay? If you look into the... All right, so let me give you the explanation of how to find the mean, okay? Mean or average value of a sine or cosine function, okay? There are two aspects to this. You find this over a complete cycle, which is capital T, which is what is asked in the question, complete cycle. The second thing you can do is calculate this across half the cycle, which is half the time period, half the time period, half the time period. So if you look into this graph, for example, of a sine function, the sine function, for every corresponding value of velocity at any instant, there is a negative value. So there is a maximum value, there is a minus maximum value. there is a value, there is another value which cancels it. So if you look into the average value of a sine or a cosine function over a complete cycle, the answer is the V average comes out to be 0. Or if it is displacement, the displacement also for a sine or a cosine function which is there in the simple harmonic motion is also 0. The acceleration average will also be equal to 0 because the cancellation effect of the positive side and the negative side. However, if you are asked in the question how to calculate the mean and average value for half the time period, right? So if you are given half the time period, just this part, this is not 0. To do this, what you need to do is you need to find the maximum value, V max, for example, or A max or X max, right? You know these values. What you do is the average value, V average, the velocity of simple harmonic motion, V average, but across T by 2 will be given by the maximum value multiply by 2 by pi. This is what we need to do. So if you look into the NCERT exemplar problem, be very careful whether the question is over a complete cycle or is it over half the time period. In NCERT question, the answer is given in 2 by pi, but the question is complete cycle. So the correct answer will be 0, right? So therefore that choice is wrong. Be very careful and take note of this, whether the question is half the cycle or over a complete cycle. I hope this made sense and brought some clarity in your mind as to how to address the mean or average value of sine or cosine function in a simple harmonic motion. Alright, so first thing we need to learn is about root mean square velocity, okay? If you refer to this question, but basically I will tell you what is the meaning of the word root mean square. Okay, so let's talk about the root mean square. So if you talk about RMS, okay, refer to the question. There is a question on root mean square, so this is called as root mean square. Okay, so if you refer to the the root mean squared, the way to solve, for example, you're given multiple values of velocities v1, v2, v3, v4, okay, and these velocities occur across a time period of t. Okay, multiple values are happening of velocities across a time period. For example, if you see this simple harmonic motion, you have velocity which is like this. Just an example, it could be cosine function. So if you have to find the root mean square, what you do is you take the square of all these velocities at different time instants, whatever are given to you, and then you divide it with the time period across which these have happened. Okay, so you write this as VRMS. Okay, this is a general definition. Write all the squares of the velocity. So the velocities given are v1, v2, v3, v4, and divided with the time period across which it has happened. These velocities have occurred. Now if you look into the context of simple harmonic motion, v is given by a omega cos omega t, right? Now this is a trigonometric function. It is not this straightforward, right, where you can just do squares of velocity. The way you solve this, you use integral calculus. If you're a class 11 student, you may not have strong basis of integral calculus, right? So we will use integral calculus, and the integral calculus says the root mean square velocity of a function, which is any function, is given by the square of the function. Okay, so you do the square of this function, divide it with the time period across which it is happening, and then you integrate it and take a square root of that. If you are finding the RMS value of cos omega t functions, or you're finding the values of, for example, the sine omega t functions, sine or cosine, the answer of RMS, if you solve this 0 to t, right, the t is the time period of the simple harmonic motion, the VRMS comes out to be 1 by root 2 times the maximum value of that function. So for example, the maximum value of amplitude or velocity could be this, right? This could be V max, right? So you know this value. So if you want to find V RMS, multiply this with 1 by root 2 into V max. And where do we get this? If you solve this integral, if you solve this integral, you will get the answer. Okay, you will get the answer as a omega multiply by 1 by root 2. Okay, so this is the maximum part of it, and you will get this answer, right? So I'm giving you shortcuts because I know you're a class 11 student. You may not be aware of the terminologies of root mean square, and therefore you should know how to calculate root mean square of anything. So if you have to find the root mean square of the displacement, for example, it's a simple harmonic function and you have to find x RMS, right? You can straight away do this by saying it will be 1 by root 2 times the maximum value of the displacement. And you know the maximum value of displacement is given by what? It is given by amplitude. So the root mean value, root mean square of even the displacement can be found as a by root 2 in one line, right? So remember, what is, you don't have to really know integration at this stage. If you are a biology student, you may still find it harder. Just memorize this. The moment you will see root mean square, you will find out, first step, you will write what is the maximum value of that function, sine or cosine function. Then you will multiply that maximum value with 1 by root 2 and you will get the answer, which is the RMS value. So this acceleration. So you can find the root mean square of the acceleration also. Again, the maximum acceleration is given by omega square a. You divide it by root 2, you will get the root mean square value of a. But be careful that this particular formula of 1 by dividing, the maximum value with root 2 is only applicable to functions that follow sine or cosine omega t. If you find any other function, please use the basic formulas, or you will have to learn the complicated integral calculus. Otherwise, this should be sufficient, right? This is the basic definition, and then for trigonometric functions we use this methodology. And there are other ways which you will learn if you learn integration, or you want to learn integration. There are methods available. You don't have to worry as a physics student about them. Just remember, root mean square velocity concept is nothing but the maximum value multiplied by 1 by root 2. All right, so let's move to the next topic, which is how do we find the mean of the square functions, which is sine square and cos square omega t. So we're trying to find the mean of sine square omega t and cos square omega t functions. These appear in the expression of energy of S.H.M, right? Energy of simple harmonic motion. Simple harmonic motion. So we will now study how to find the mean of these. We have to find the mean, and we have to find the mean of these over a complete cycle. Be very careful of the word complete cycle. That is what you need to be careful about. Just a quick word on the expression of energy. So if you see the energy of a simple harmonic motion, it has two parts: kinetic energy and potential energy, right? The kinetic energy is given by half mv square, whereas the potential energy is given by half kx square. And you can write this as half m. So this is instantaneous velocity at any time, so therefore you can replace it with a square omega square cos square omega t, and x, which is the displacement, is also instantaneous, can be replaced with a omega a square omega square sine square omega t, right? So this is the expression of kinetic energy instantaneous, and this is the expression for kinetic potential energy instantaneous, right? So if you have to find the maximum kinetic energy, ke max, right, which is at the position when it is back, the t is equal to 0 degree, right? At the velocity is highest when it is coming back, right? So this goes here 90 degrees and it comes back another t by 4 and t by 4 both correspond to t by 2, and therefore when you put the value of t as t by 2 here, what you get is half m a square omega square. So this is your kinetic energy, the maximum kinetic energy for a simple harmonic motion, and the maximum potential energy of a simple harmonic motion is also the same, half k a square omega square. Mind you, you must understand what is ke max expression. You must know this, and you should also know the pe max expression. Both are identical, but it will help you if you memorize this. Thank you very much. Right, so if you have to calculate the mean of sine square theta and cos square theta, don't worry, you can write theta as equal to omega t. The mean of these, okay, the mean value of the sine square and cos square theta can also be found out, and it's not very difficult. What you need to do, it is equal to half the maximum value. Maximum value. This is the basic formula. So if you are given a function occurs, if you know the maximum value of that thing, which is this, what you need to do is just this, that the mean value is equal to the mean value of the function will be given by a max divided by 2, right? So you're given any function y is equal to b cos square omega t. You have to find the mean value of y through the whole cycle. Remember the word whole cycle. So it will be the mean value of y mean over a whole cycle will be given by half of the maximum value. So the maximum value is b. Just multiply it with b. Right? I hope this is making sense. So if you have to find the mean value of sine square and cos square theta, please use this strategy. Right, now let's start solving this. Okay, so first of all, its average total energy per cycle is equal to the maximum kinetic energy. Now we know what is the maximum kinetic energy, right? So the maximum kinetic energy, ke max, right? I'm doing the a. So ke max is given by half mass velocity square, a square omega square, right? So it's average total energy per cycle. So energy is basically sine square or cos square function. We have studied this in the explanation, right? So you know that the average total energy, right, will be how much? Energy is given by this, the average kinetic energy, will be given by half of this, right? We know that we have to multiply this with half, right? It is half of the ke max, so it is half of ke max. Now if you talk about potential energy, the potential energy, which is the balance of the energy, right? The maximum value of potential energy is also the same, ma square omega square, because the energy keeps on fluctuating between kinetic energy and potential energy. The maximum value does not change, it's flat. So if you talk about the total average energy per cycle, the total average energy per cycle will be equal to the average of kinetic energy plus the average of the potential energy, right? So what is the average kinetic energy? It is half of ke max. And what is the average potential energy? It is again half of ke max or pe max. These two are equal, so you can also write this as ke max, right? Which is equal to, right, 1 by 2 into half of ma square omega square plus half of ma square omega square is equal to half ma square omega square. So that's your total average energy, right? So this is your total average energy. Now if you see this total average energy, TAE, what is it? This is what? This is the, if you see the kinetic energy maximum and you see the total average energy, they come out to be the same. So the first answer is true, right? How we did that? We calculated the total average energy, which is the sum of average kinetic energy and average potential energy. We know what is the value of average kinetic energy and the average potential energy. We added the two and got the answer as total average energy, right? So TAE, the total average energy, is known to us per cycle, right? It's a sum of the two energies, and we got the answer, right? So you can see, so this is true. The second part is the average kinetic energy per cycle. The average kinetic energy per cycle, so the average kinetic energy per cycle is equal to half of its maximum energy, which is also true. We've already studied this, right? So this is true already. You can see the factor of 1/2 getting applied, right? So straightforward. So this is also true. All right, so let's talk about the mean velocity. We are doing the part C now, right? The part C. So the mean velocity, what I mentioned here is for half the cycle, right? So mean for T/2, right, is okay. So if this would have been, over half a cycle, this would have been correct. But here it says complete cycle. So if you have to calculate the mean for a complete cycle for a sine omega t function or a cos omega t function, the answer is 0. The mean of sine omega t and cos omega t over a full complete cycle. This is very important, right? Note this word, complete cycle. So be very careful when you solve these questions of mean or any other question pertaining to averages. The problem you will face is whether it's half the cycle. So half the cycle, the answer is multiply by 2/pi. If it is over a full cycle, it's full cycle, the answer is 0, right? We have given the explanation in the explanation part of this. So now you understand, and remember the word, the average and mean are one and the same thing, so don't worry about it. Let's solve the root mean square velocity. Velocity is expressed either in terms of sine or cosine, right? So if these are expressed as sine or cosine, you know the RMS is calculated by multiplying the maximum value with 1/√2, right? So this is also true, right? If you see, all the four parts are very mathematical in nature, and therefore I took a lot of pain in explaining you how to go about this. This particular one, which is the average total energy, was different, but if you apply your common sense, you can calculate that also using this particular expression. So I hope this video made sense to you. The idea was to help you understand the meaning of the word root mean square, mean, and the averages as applied to trigonometric functions. That becomes a problem for students, and therefore it is important that you place this in your head so that you never forget it. You know the factors, you understand them very well, and you're able to solve them immediately without any problem. So thank you very much for your time, and I just wait